Discover how artificial intelligence is transforming the architecture discipline from the ground up. This comprehensive guide reveals practical steps to integrate AI tools, establish effective human-AI collaborations, and maintain critical oversight in your architectural practice. Keep scrolling to unlock the future of architecture. AI tools aren't just supplementing traditional architecture practices, they're completely reshaping how architects conceptualize, design, validate, and communicate complex systems. Success requires both technical adaptation and psychological readiness to embrace new workflows that combine human expertise with AI capabilities. The architecture landscape is being redefined through AI integration, creating opportunities for those willing to evolve their practice. Architecture diagrams once required hours of manual effort in tools like Visio or Lucidchart. Now, AI is revolutionizing this process across all levels of architectural abstraction, from conceptual to implementation diagrams. This transformation is saving architects countless hours while enabling more creative exploration of design alternatives. Miro AI Assistant rapidly generates high-level conceptual diagrams from text descriptions, automatically arranging components based on best practices. Midjourney for Architecture creates initial conceptual visualizations that can inspire more technical diagrams, bringing artistic elements to architecture planning. Excalidraw plus GPT Vision transforms rough sketches into polished conceptual diagrams, maintaining creative freedom with digital precision. Lucidchart AI Assist generates logical system diagrams from textual descriptions of system behaviors and relationships, automatically applying appropriate notation. Microsoft Copilot for Visio transforms requirements documents into logical architecture diagrams, suggesting appropriate relationships between components. Structurizr plus GPT integration combines C4 model approach with AI assistance to generate consistent, hierarchical views of software architecture from code analysis. Cloudcraft with AI automatically generates AWS architecture diagrams by scanning existing infrastructure, with AI suggesting optimizations and best practices. Diagrams as Code plus GitHub Copilot allows architects to describe infrastructure in code while AI suggests improvements, validations, and optimization patterns. Enterprise Architect's AI Assistant helps generate detailed UML diagrams from requirements and existing code bases, maintaining consistency across multiple views. Use AI to rapidly generate multiple candidate diagrams based on requirements or existing system descriptions. Architects review, combine, and refine the generated diagrams, applying domain knowledge and stakeholder context. AI suggests design patterns, identifies inconsistencies, or generates alternative views for different stakeholders. Use AI as a participant in design workshops, rapidly visualizing ideas as they emerge in discussions. JAMA Connect with AI Analysis identifies requirement gaps, ambiguities, and inconsistencies across large requirement sets, helping architects focus on quality issues. IBM Watson for Requirements analyzes natural language requirements to detect quality issues, suggesting clarity improvements and highlighting potential conflicts. Requirements GPT uses specialized models to transform vague stakeholder statements into precise, testable requirements following SMART criteria. AI scans requirements for words with multiple interpretations, vague quantifiers, or undefined terms that could lead to misunderstandings. It identifies missing requirements by analyzing patterns in similar projects and reference architectures, ensuring comprehensive coverage. AI detects potential conflicts between requirements across different domains or stakeholder groups that might cause implementation issues. It evaluates requirements against known technology constraints and implementation patterns to ensure feasibility. A financial services organization reduced requirements validation time by 70% using AI to scan 3,000+ requirements for a core banking system replacement. The AI flagged 15% of requirements as potentially problematic, helping architects focus their attention where it mattered most and significantly accelerating the project timeline. Many architects build their identity around being the most knowledgeable person in the room. AI challenges this by providing rapid access to patterns and solutions that may exceed an individual's experience. Architects must develop a healthy verification relationship with AI outputs, neither blindly accepting nor reflexively rejecting them. Successful architects reframe AI as extending their capabilities rather than replacing their value in the organization. Establish processes to feed AI outputs back into organizational knowledge bases. Rapidly generate and evaluate multiple design alternatives in parallel. Explore wider solution spaces early in projects. Select and refine AI-generated content rather than creating from scratch. These process changes fundamentally alter the traditional waterfall of architectural definition, enabling more agile and comprehensive exploration of solutions. Despite AI's capabilities, human architects remain essential for providing critical oversight and judgment. The most successful architecture practices establish clear touchpoints where human expertise is deliberately applied. This human-in-the-loop approach ensures AI serves as a powerful tool rather than an unquestioned authority. Humans must define the business context, constraints, and unique factors that AI cannot infer from general knowledge. They are integral to integrating insights across domains in ways that domain-specific AI may struggle with. Humans must evaluate AI-generated architectures for alignment with organizational values, ethics, and cultural factors. They remain essential for translating between stakeholder concerns and technical solutions, providing empathy and relationship management. Include specific steps where humans verify AI-generated content against domain knowledge and organizational context. Clearly mark which aspects of architectural artifacts were AI-generated versus human-refined to enhance trust and accountability. Identify where AI recommendations fall short to create opportunities for improving future AI performance through additional training. AI-powered natural language processing can transform stakeholder discussions directly into structured requirements, capturing insights that might otherwise be lost. Automated checking of architecture diagrams against best practices, security standards, and compliance requirements ensures consistent quality. Automated creation of architecture documentation from diagrams, code, and meeting notes saves countless hours of manual documentation work. Automated maintenance of relationships between requirements, architecture decisions, and implementation artifacts ensures consistency. Successful AI-augmented architecture practices establish integration pipelines connecting multiple systems to provide AI with comprehensive context. Systems that capture and organize stakeholder needs and constraints. Platforms for creating and maintaining architecture diagrams and models. Systems storing actual implementation code and configuration. Wikis and documentation systems containing organizational knowledge. AI excels at translating the same architectural concepts for different audiences, ensuring each stakeholder group receives information in the format and detail level most useful to them. Executive summaries for business alignment, technical details for design and implementation, and operational insights for support and maintenance implications. AI can detect concerns or resistance in stakeholder comments during architecture reviews, helping architects address issues before they become obstacles. It identifies when stakeholder feedback conflicts with previously stated requirements or constraints, highlighting potential misalignments. AI can predict likely questions or concerns before they arise, allowing architects to prepare comprehensive responses. AI analyzes past interactions to build profiles of stakeholder preferences, concerns, and communication styles, enabling more effective presentations. It creates presentation materials that emphasize aspects most relevant to specific audience segments, increasing engagement and understanding. Automatically adjusts terminology, detail level, and examples based on audience technical sophistication, ensuring clarity for all participants. AI enables architects to generate visualizations on demand during presentations based on audience questions and feedback. Interactive exploration of architectural alternatives during presentations to address stakeholder concerns and demonstrate flexibility. AI-generated customized follow-up materials addressing specific questions raised during presentations, ensuring comprehensive communication. AI helps architects understand and model different stakeholder perspectives, creating a more inclusive and comprehensive architecture approach. Creating models of key stakeholders that simulate their likely reactions to architectural decisions, allowing for preemptive adjustments. Analyzing how the same architecture will be perceived differently by various stakeholders, highlighting potential communication challenges. Identifying when architecture decisions may inadvertently favor one stakeholder group over others, ensuring more balanced solutions. AI models the implications of different architectural choices across competing priorities, making trade-offs explicit and discussable. AI finds shared values and concerns across divergent stakeholder perspectives, creating foundation for consensus. AI automatically documents reasoning behind architectural decisions for future reference and stakeholder alignment. Provide comprehensive business and technical context in AI requests to get more relevant and accurate responses. Clearly define boundaries, limitations, and non-negotiable requirements to guide AI toward feasible solutions. Use examples to illustrate desired outputs and quality standards, helping AI understand your expectations. Build on initial AI responses through progressive refinement cycles, gradually improving output quality. AI can identify relevant patterns from industries outside the architect's experience, bringing fresh perspectives to architectural challenges. AI connects current decisions to historical outcomes across similar projects, helping avoid repeated mistakes and leverage proven approaches. AI incorporates emerging technology trends that may not yet be widely known, keeping architecture forward-looking and innovative. AI may generate plausible-sounding but incorrect or non-existent architectural patterns, especially at the cutting edge of technology. AI training cutoff dates mean awareness of recent technologies, standards, or best practices may be limited or outdated. AI lacks awareness of organization-specific constraints, politics, or history unless explicitly provided in the prompt. AI may over-standardize architecture approaches, missing opportunities for innovative differentiation that could provide competitive advantage. Architects accepting AI recommendations without verification, potentially introducing errors or inappropriate solutions. As AI handles more tasks, reducing the architect's ability to function independently. Attributing architecture decisions to AI rather than taking professional ownership, undermining accountability. Applying AI-generated patterns without considering organizational fit, leading to misaligned solutions. Compare AI outputs against multiple authoritative sources for confirmation of accuracy. Have subject matter experts review AI-generated content to identify potential issues or improvements. Test architectural concepts in low-risk environments before wider application to ensure reliability. Compare AI recommendations against historical outcomes in similar contexts to assess likely success. AI identifies patterns in training data that match the current architectural context, applying learned solutions to new problems. AI generates content by predicting the most likely next elements in a sequence, which can sometimes lead to conventional rather than innovative solutions. AI optimizes for internal consistency, sometimes at the expense of external accuracy or practical implementation concerns. AI extrapolates from known examples to novel situations, with varying reliability depending on the similarity to training data. The integration of AI into architecture practice represents a fundamental shift in how complex systems are designed, documented, and communicated. Successful architects will develop a symbiotic relationship with AI tools that enhances human creativity, insight, and judgment while automating routine aspects of architectural work. The architect of the future will be distinguished not by their ability to manually create every aspect of an architecture, but by their skill in orchestrating human and artificial intelligence into a cohesive whole that delivers superior outcomes.